Okay, so this seems like a polynomial inequality question. So you're looking for how many integers n. So we're looking for integers n, no positive integer, negative integers mentioned. So that's just an integer. Will the inequality this hold true? So I'm not finding any direct shortcuts here. So let's open this up. So let's say n square minus 15n plus 50 minus 3n plus 6 less than equal to 0. So what we have is effectively n square minus 18n plus 56 less than equal to 0. At this stage, I can do a couple of things. I can actually break it up into, factorize this, or sometimes I'll show both methods here. So method one, let's say, you factorize this out. So you write this as n minus 4 into n minus 14. That will be the factorized form. You can middle term factorize this is less than equal to 0. In that case, you're getting 4 to 14. I mean, anything in between these two. So I hope you understand this part. So this has to be understood. So if you have n greater than 14, then this will be positive, this will be positive. So it doesn't satisfy this condition if n is greater than 14. So it doesn't satisfy here. Now, if n is lying between 4 and 14, then this part will be negative and this part will be positive. So this will be negative in nature. So this part is satisfied. I don't have to mention, I believe, that n equal to 14 and n equal to 4 is also satisfying. But if n is less than 4, then this is negative as well as this is negative. So negative into negative becomes positive, but I need a negative, non-positive thing. So that is also out. So anything in the range of 4 to 14 will satisfy. That will be 4 to 14 total of 11 solution. Even 4 and 14 are acceptable. So this is using method 1. Now method 2 in these kind of cases are a bit faster if you can make a whole square here. So notice that this is an even number. So whenever this is an even number and you don't have as a coefficient here, that becomes very easy to make a whole square. So all you have to do is just write this n minus 9 whole square, because if you remember a square minus 2ab, right? So half of 18 is 9. So this must be 9 square. You don't have to write that 9 square. What I'm going to do is I'm just going to try to balance both sides. So on the left hand side, on this part, we should have n square minus this 18n plus what do we have? 81, right? Now 81 is how much more than 56? Just compare in this way. So let me write it here. You would have had an 81 here. Now 56 to 81, you're effectively adding how much? 25. So in order to balance this, you need to add 25 on this side as well. So you need to add a 25 here. So this becomes 25. Now you'll notice that this is 5 square. So essentially what does this mean? N minus 1 square less than equal to 5 square implies the value of this n minus 9 ranges from minus 5 to plus 5. That's it. Now, understand another important idea here. This is why I pointed out on the integer part. If n is an integer, then n minus 9 is also an integer, and vice versa. Converse is also true. Implies that as many solution you will have for n minus 9, you will have that many solution, that many corresponding solution for n. So if you have a total of 11 solutions here, minus 5, 2 plus 5, 5 negative, 5 positive, and the 0. So if you have 11 solutions, integer solutions for n minus 9, then correspondingly you will always have 11 integer solutions for this value of n. So the answer in this case is 11, however you want to do it. In this case, I would prefer method 2 because this is a little faster. You have this minus 5 plus 5 thing happening. Even if this was not a whole square, you could always have identify the highest square that you can go to, right? I mean, if this would have been something like 40 or something, then you can take n minus 9 as minus 6 to plus 6 because we are concerned with integer numbers only. So this is a little easier way to solve this, or you can use the polynomial inequality. Depends on how you're solving this. So roughly 1.5 to 2 minutes for this question. That should be the ideal time to solve this question. So that's it for this problem. So thank you.